Hello everyone, my name is Sharvin Rao. I'll be presenting the objectives on our projects. These are the objectives of our projects, which is to develop and apply a MATLAB GUI that is easy to use and intuitive for the link budget calculator. The next objective is to implement the link power equation within the MATLAB software to accurately represent the link budget. And the next one is to develop a MATLAB GUI code for the calculator, which is for the project. That's all from me. Thank you.
Okay, Assalamu alaikum. My name is Rabi Abdullah and I will present for the Group 17 report. For the introduction, simulation programs are used to include environmental elements that impact signal and monitor satellite connection performance for evaluating and testing satellite communication system. An uplink and downlink may comprise an RF satellite communication. The strength of the signal when it leaves the Earth station and how the satellite receives it determine the signal power and quality over the uplink. On the other hand, how will the satellite can retransmit the signal and how the Earth station receives it determine what happened on the uplink side. In order for the signal to reach the satellite, it must first be perceived by the Earth station. The transmission procedure involves applications, amplification, frequency conversion, and modulation. A narrow beam antenna will then deliver the signal to the satellite. Then signal will look people do the attenuation and huge loss in empty space, resulting in the satellite receiving a full signal. In order to transfer the signal from uplink frequency to downlink frequency, considerable processing and signal amplification are required. What is link budget? In networking, and telecommunication, a link budget is a summary of all the gain and loss a transmitter experience while it is in an active state. A transmitter's responsibility is to assure signal transmission while connecting with the receiver in an open area via a media like wireless, optical fiber, or copper wire. This includes encoding the signal and carrying out certain signal operation. It is vital for the transmitter and receivers to monitor these loss and gains in order to gauge the dependability and efficiency of connection. Moreover, techniques are used to reduce data loss by broadening the medium bandwidth and diversity of antenna. However, a connection budget is frequently created for radio and satellite receiver service where noise and loss are usually considerable. Why we need it? Various gains and loss might happen when satellite system is communicating. The production of these gains and loss result in many aspects that impact the satellite system performance. This analysis on the gain and loss must be used in order to control the system performance. One of the most important components of a satellite communication system is the link budget computation. The computation of the link budget will optimize the system numerous profile and loss. For the safety and legal issue, for the safety issue, the space time began in 1961 when the first satellite. Since then, satellites have been a key component in the rapid advancement of communication based technology. It currently forms a circular component of our society, information technology, helping people, business, government, and military. The failure of satellite service, particular communication, is therefore one of the safety issues. Natural disaster like accident with space debris or terrorist act of assault can also create disruption. Whatever the reason, an interruption like this might cost business millions of dollars. It may also interfere with people's ability to communicate and exchange information, as well as make it difficult to operate many devices that depends on the service. The possibility of a terrorist strike and following chaos and problems might lead to widespread panic. For legal issue, the cost of launching a satellite into orbit has dropped dramatically over the past several years, making it increasingly feasible for business to do so. However, the regulation and legalities surrounding this technology have not kept up with this development. The focus of the legality debate then shifts to its absence and attempt to mod- modernize it. The accords that were established at that time have not been updated to reflect the latest advancement satellite technology. The accords have not taken into account the recent commercialization of satellite technology, often assuming that the state is the principal handler of this technology. The legal environment is fragmented due to the difference in the legis- legislation governing state-run and commercial satellite systems.
Hi, I'm here to present my procedure for my assignment. So, looking at my objective, to develop an intuitive MATLAB graphic user interface which is GUI for a link budget calculator. The link budget formula assesses gains and losses in the communication link to predict system performance. Utilize MATLAB to analyze and calculate link budget parameters such as transmitter power, antenna gains, and free space part loss. Implement basic formulas for link budget calculation, and then we design GUI components for easy user input of parameters, set parameters for each link budget through the GUI, then implement callback functions for each GUI component to update properties based on user input, then calculate link budget and record simulation result, compare theoretical values with simulation parameters to validate accuracy, address safety and legal issues related to satellite services, emphasize the importance of considering potential disruption and the need for updating regulation. Document the entire process including MATLAB code with the clear comments. Compile a comprehensive report for submission. Thoroughly test and validate the GUI to ensure it operates as intended. Make necessary iteration for enhancements based on testing feedback. Include all documentation, code files, and the file report in the submission package. And then we ensure compliance with the assignment requirements and guidelines. So looking at quality assurance, so we prioritize thorough testing and validation to guarantee the accuracy and reliability of a link budget calculation. Now iterate and enhance the GUI based on testing results to improve user experience. And then if you look at the regulatory awareness, we acknowledge the importance of staying updated with the safety regulation in the satellite services. Then we highlight the necessity to address potential disruption for a robust communication system. Then, for transparent code, we maintain transparency in the MATLAB code by providing clear commands for better understanding and future modification. Uh, Looking at the continuous improvement, we demonstrate a commitment to continuous improvement by addressing any identified shortcomings during the testing and validation phases. Submission, and then once we get done all the calculation and then improvement, last thing we ensure the submission package is organized and complete, meets all the specified assignment requirements. That's all for me. Thank you.
My name is Intan Yushaira. So for now, I will explain for the simulation and results. Okay, here, uh, this is the link budget calculator designs that we have designed in MATLAB App Designer, and basically there are two sections in this link budget calculator, which is the upper part is to insert data, and the bottom is where we obtain the results by simply click the compute button. Okay, first of all, how the compute button work is by define the functions in this code here. Okay, uh, so I will explain the functions for each of the lines. Okay, the first one we have compute button value change. What means by this line is this line declares a function which is a callback function that handles the event when the parameter value for the compute button is changed, and this apps represents the app object, and this event contains data about the event that triggered the function. And the second line here is value is equal to add compute button values, where these lines retrieve the current value of the compute button from the app interface and stores it in the variable value. Okay, so the next one is the third line, which is an A is equal to app frequency edit field that value, and here is the value that we insert in the data insert part, and which named as frequency edit field is retrieved and assigned to the variable A. Okay, so the fourth line here, the fourth line is calculate, where we calculate the wavelength using the formula. Okay, this is the formula, which is 3 is multiplied by 10 power of 8 and divide by A, which is the A is the frequency we put the value earlier, and use the data from this A to obtain the results, which is the result is for wavelength. So the fifth line is the calculate wavelength that we obtain is then set as the value of an edit field named wavelength edit field in the app interface. Okay, so the last one is the end. This marks the end of the first function. Okay, so same goes for all of the functions. For this function, for the compute button 2, compute button 3, and also until the last compute button. Okay, so the function is to serve to update other parts of the app with calculated values whenever we change the value in the insert data sections. Okay, so for now, let's observe the simulation results. Okay, so this is the link budget calculator. Okay, the upper, like I mentioned earlier, the upper part is the where we insert the data, and the bottom is where we obtain the result. Okay, so we need to put the value in each of the parameters, and where this is the parameter, and this where we input the value, and this is the units. Okay, each of them have each of the parameter have the different units. Okay, next we can also convert power in watt to dB by insert the value in watts and click this convert button, and we will get the value in dB, which is I put here the power is 30 watt, and just click the convert button and we will get the result in dB. Okay, so we get 14.77 dB. Okay, so next, the second section is where we obtain the results for the calculations. So after we insert all the data above, we can easily click the compute button to get the output. And this data here means that which parameter involved in the calculations. Okay, let's say we want to calculate the receiver gain, which is the data involved is AE and also lambda. So we need to put the values in the wavelength lambda and also in the effective aperture AE. So for example, our AE is equal to 0.021 and the lambda is equal to 0.216. So we just can simply click the compute button and we will get the results, which is GR is equal to 7.525 dB. And then same goes to the other parameters that we want to calculate, and just put the values here and we can click by and we can get the result by simply click the compute button. So that's all from me. Thank you.
Hi, my name is Sunisa. So now I will explain the calculation part. So this is when the parameter involved is lambda, and the calculated value we get is 0.375, which is the same as what we have done in MATLAB GUI result, which is 0.375. And the next one is effective aperture, and we get 0.021 m squared. Next is the antenna aperture, and the distance we put is 0.4, and the answer that we got is 0.126 m squared, which is it was the same as the MATLAB GUI result. Next is transmitted gain, and the calculation that we get is 5.63 dB. And the MATLAB GUI result that we get is 5.629 dB, which is it was almost the same, just because of the point it was different. Okay, next is the receive gain. The calculated value that we get is 7.53 dB, and the MATLAB GUI result that we get is 7.525 dB. Next is effective isotropic radiated power, EIRP, and the answer that we get for the calculated one is 15.26 dB, and the result from the MATLAB GUI that we get is 15.26 dB. Next is the receive power. The calculated answer that we get is negative 38.70 dB, and from the MATLAB result we get negative 38.71 dB. Next is the transmitted power. The calculated value that we get is 14.77 dB, and in the MATLAB GUI result we got 14.77 dB, which is the same as the calculated value. Next is the flux density. the value that we get from the what we have calculated is 1.068 milliwatt per m squared, and from the MATLAB result we got the same answer. Next is the path loss. The calculated value that we get is 65.88 dB, and the result that we get in MATLAB GUI was the same. The next one is figure of merit. So the calculated value that we get is negative 21.53 dB over Kelvin, and you can see from the MATLAB GUI result we get negative 22.97 dB per Kelvin. And the last one is the carrier power to noise ratio, and we get negative 22.81 m, and from the result in MATLAB GUI we get the same answer. So that's all from me. Thank you.
Hi, my name is Nuri Nadia, so I will continue the discussion part. A link budget is a formula that assesses all gains and losses in a communication link that occur between the transmitter and receiver to forecast how well a communication system will operate. By using MATLAB software, the program analyzes and calculates the basic formula that are related to the link budget. By using the GUI or MATLAB software to design link budget calculator, the graphical user interface is a graphical display in one or more windows containing control call component that enables the user to perform interactive tasks. So in this project, we set the parameters of each link budget and design the GUI. All the components are used to display the input various parameters that are used in link budget calculation. Following this, we calculate the link budget and recorded the data as shown in the result simulation. Therefore, we create a callback function for each component to update the properties of GUI component based on user input or change that will be used to perform calculation. Last but not least, after we got the output simulation, we compare the theoretical value and the simulation parameters value. I will pass the conclusion part to the next presenter. Thank you.
So to conclude this project, we have successfully achieved all the stated objectives, which is the first one, which is to create a user-friendly and intuitive MATLAB GUI for the link budget calculator, providing an efficient platform for users to interact with the tools seamlessly. And the implementation of the link power equation with the MATLAB software has been accomplished too, ensuring accurate representation of the link budget. Additionally, the code for the link budget calculator has been successfully developed, meeting the criteria based on the flowchart given in the question. So the project outcomes collectively demonstrate a robust and effective solution for link budget analysis, contributing to the facilitation of communication system design and optimization. So that's all from me. Thank you.